Okay. So I will give it in the presentation mode.
Okay.
Okay. So at first, I mean, this is the topic that we are going to talk today: existing and next generation batteries. And I'm actually currently working as a battery system engineer at OMI Motors, which is based in Texas, Houston. So there will be a short introduction about me. I mean, why I'm in here and why I was invited. So I'm Ikramul Hasan Sohel. I am doing my PhD in Istanbul Technical University. Maybe you can see behind me, the logo is from my present university. I'm doing PhD there, and it's about to finish. And I am also working as actually I am working in battery sector for last 3.5 years, and mostly I am involved in battery R&D from the material perspective to the battery pack. I mean, from scratch to the battery pack, all of the section I have been working on for last 3 years. And I have also worked in a European cell manufacturing company for a couple of months. And then I got an offer from this American company where I'm working now. But I'm working from the distance now. There is some processing going on. Hopefully, I will be in USA shortly. So actually, the battery, lab that I worked is in Turkey, and my university is also in Turkey, Istanbul Technical University. So this is a whole R&D based laboratory that where I worked on, and is fully specialized for battery, mostly lithium and battery. We have heard about the lithium and battery, and you are hearing about it. It's very trending because of the electric vehicle that the world is gonna adopt in next 5 to 7 years. Actually, in Europe, within 2030, there will be no combustion engine car on the road. They are switching fully electric vehicles in 2030, and I guess America have also set that goal as well. So the topic is very much trending and currently very hot topic as the things to research, as the job field, everything. So let's start together, and hopefully you will enjoy the session. So that's the content that I'm going to talk on about the battery. At first, I will give you a very good introduction of the battery system, because I know the audience is not fully focused on chemistry or electrochemistry. So I will be first giving some introduction on the battery systems, what it actually is, the type of the battery, how it works. Then the basics of battery, how it works, how it stores the electrochemical energy, and then how it exert the energy. Then the existing battery technologies that we have in the market that you can go in the market and buy. So there are a couple of battery systems that is already existing in the market. And then there will be next generation battery technologies, which is actually based on lithium and battery because of its energy density and all of the application in electric vehicle. And then summary at the and at last there will be Q&A session. I will let us ask you a question if you have any question from this class today. So at first I will start from the battery systems. I think you all of you are using at least every day the dry cell, maybe in your remote control, in your watch, watch mounted on the wall. Everyone is using this dry cell. This is actually primary cell, and there is one which is you are using in your cell phones, in your smartphones, that is actually lithium and battery. So actually primary cells are that cells that you cannot recharge. So there are two major types of battery. One is a primary cell, which is non-rechargeable. You cannot recharge it. You can just use it and throw it in the trash. And then there is secondary cell battery that you can recharge thousands of times, if not couple of thousands of times. So and it can last even 5, 10, 15 years. So there are also, maybe all of you have heard about it, the battery of lead acid battery. Maybe you have also heard about it, because this is the mostly used battery in our car right now, because we use it as a starter. The car electronics, these are used by lead acid battery. So actually, lead acid battery is also a type of secondary battery, but the type of battery is actually two: primary and secondary. So at first, I will try to give you an overview, actually, how battery stores energy. Because when we say, okay, battery stores energy and it gives us energy when we need it, but how it actually do that one? For example, if we think the lithium ion battery, let's say there are some places where you can put some lithium on, and if the space is enough to feed the lithium, it should be staying there, right? So the thing is, in lithium ion battery, the mostly used and the very common place where the lithium stores is carbon. And carbon has a, or graphite. Graphite has a hexagonal structure, as you can see in this. I can use a laser, as you can see in this structure. And there is also a gap between the hexagonal planes, because it's graphite. And this hexagonal area that you can see here is in the size of 0.14 nanometer, which is written here. And the lithium ion is way lower than this place. So when we can store energy, that means lithium, this lithium fits well on this carbon, which is actually graphite. So the thing is, when we charge a battery, for example, if we are thinking about lithium ion battery, then it actually goes through the electrolyte and then stores in the carbon. I will explain everything with a diagram. I'm just giving you an overview how it's actually doing the charging. And during discharging, actually, it exerts, it again go back to its previous place, and then the electron comes out, because there are some excess electron that holds lithium. When the lithium releases, this electron also releases, and that's how you get the energy in the outer circuit. So at first, let me tell you something about the chemistry. And if you want to understand the chemistry at first view, you should know the periodic table a little bit, at least to have some idea. So the thing is, there is hydrogen, which is at the top, and the atomic number is just 1. And if you see that just below hydrogen, there is lithium, right? So the lightest metal after hydrogen, or alkaline metal after hydrogen, is lithium. And also it is the lowest in size. If you see this, this also lowest in size, because it's just after the hydrogen. And if you go from top to bottom, the size of the element, the size of the atom increases, because the atomic number increases. So lithium is the possible and the lightest metal that ever discovered in this world. And we are dealing with this lithium ion battery. And it is easy to do that, because lithium is very tiny in size, and you can just put it through the electrolyte to the other side of the storage place mechanism. That's why lithium is here. So you can see that there is sodium. Actually, sodium ion battery is also available. People are working on potassium ion battery as well. But if you can think which one could be the highest in energy, that is lithium. Because if you have, for example, 1 square meter of place, and if you have the lowest and smallest size of the balls, then you can place them more in that area, right? So if lithium is the lowest size and lightest metal, you can put the lithium as much as possible, but sodium and potassium would not be that much in number, if you think about the storage mechanism. So I don't Actually, there are some lines. I don't know why these lines are here. But it's okay, I guess. There is no problem, I hope. So the thing is, if we want to know the battery, we need to understand the anode, cathode, and electrolyte. So the thing is, when a battery stores energy, it actually stores in anode, and when it releases energy, it goes to cathode. So how it is going on actually? So this electrochemical reaction, depending on intercalation and deintercalation. That means lithium is alloying when it is charged, and then it is dealloying when it is discharging. For example, if this is a lithium ion cell, and we have a charging system here, and if you put a charger here, the lithium that is available in the cathode, maybe it can be a lithium metal, it can be a lithium composite. This lithium travels through this electrolyte and goes to this anode, and in anode there is carbon here, and this lithium stores itself and is deposit itself inside this hexagonal structure that I have shown earlier. So this lithium goes here when we have force, external force, which is charging system from the external electricity. This actually force this lithium go into the anode and stay there. This is charging process. What you can see here, this is actually discharging process. The discharging process is actually the opposite of a charging mechanism. When the lithium is already available in the anode, and then you are trying to get the electricity from the external circuit, this lithium is actually now traveling through this electrolyte to the cathode. And you can ask, okay, why only lithium ion is passing? Why not the electricity is passing through this electrolyte? Actually, this electrolyte is made in a way that it can only transfer ion, not electron. That's why this electrolyte is ionically conducting, not electronically conducting. That's why there is no short circuit inside this, and there is also a separator inside at the middle of this anode and cathode. And this separator has very small ports that allows this lithium to go through this electrolyte. And the port size are small enough that only lithium can travel through this separator. So if you can see here that lithium ion anode is storing, and when it is discharging, it is going through the cathode. Actually, there are a couple of cathodes that is using for lithium ion battery. There are lithium cobalt oxide, which is LCO. There is another one which is called LMO, lithium manganese oxide. So lithium salts, I don't know why these lines are coming. Mr. Wilson, can you sure there are some red lines are coming? Is anybody controlling this?
Not
screen?
that I know of, actually. I thought those lines were printed by you on your end. There is nobody that has control
actually,
of your document.
okay. But I'm actually using lasers, but I can see lines. I'm using this.
It has to be on your end, because, as I said again, I am hosting the event, and I'm not aware of anybody from our technology department that has some type of control over your presentation. So we've got to manage to deal with it, since, you know, we can fairly see what's going on. If you're not the one
maybe
putting those lines,
maybe I can stop share and then again share it. I hope it will be okay now.
Okay, let's try that then. That's a very good option. The lines are gone.
Yeah, that's good then.
As I said,
yeah, it was irritating us. Sorry for that. So there are some electrolyte options, which is actually a lithium salt, and this is lithium hexafluorophosphate. One of them is lithium hexafluorophosphate, which is mostly used. in the lithium-ion battery domain. So that's how the lithium-ion battery, actually all of the battery that is working and which is rechargeable actually work in this way. When you are storing energy, this is actually storing energy in anode, and then when it is discharging or giving you energy or electricity, this is actually going from anode to cathode, and the outer circuit is what is getting the electron, and then the electricity is actually passing through that. So now I will try to explain some existing secondary battery technologies which is available in the market, and then I will go to the lithium battery eventually. So if you can see this screen properly, and there are some battery technologies which is mentioned here. Lead acid battery that you all know. There is nickel cadmium battery. There is nickel metal hydride battery. So the thing is, the x-axis is actually showing you the energy density, and the y-axis is giving you energy density in watt-hour per liter, and it's watt-hour per kg. So the thing is, the right, when you go to the right, you have more energy. When you have go to the up, you have more power. So when you are getting to that lead acid is actually the lowest energy possible in terms of its size, and because it's depending on the kg, watt-hour per kg. Then if you go forward, you will see that there is nickel cadmium right next to lead acid battery, then nickel metal hydride battery, then lithium ion battery. If you can see here, lithium ion battery is staying here. That means it has good energy and good power, which is enough to run an electric vehicle. So actually electric vehicle needs a very high power to run. And then there is one which you can see is the red one, lithium metal. It's written unsafe. Why it is written unsafe? The reason is when we are using lithium metal as cathode, there is a risk of dendrite formation. Actually, this can give you the highest energy density, but during the charging and discharging process, the lithium dendrite can be grown, and it can penetrate through the separator. And when it penetrates inside the separator, it can short circuit the anode and cathode, which is disastrous. That's why you hear that lithium-ion battery run car is likely to catch fire. So this is the place that people are arguing on, that if we want to make the lithium-ion battery very highly energy dense, then it will be more unsafe. But the thing is, researcher like me and the others, and the most renowned companies like Tesla, they are actually working on technology of this lithium-ion battery. That means there are a lot of materials which can reach this level of energy, but it is safer than lithium metal. So that's how we are going through this lithium-ion battery, and people are also working on it. And as you can see, it's the most trending in the market. I mean, because electric vehicle is coming, so people are also, you have heard some of them, but not all of them. When I said lead acid battery, you all know it because you all use it in your car and in a lot of places in charging systems. Small equipments like charger fans and everything like this. And there is nickel cadmium battery, which is also available in the market, and it is also used in small electric appliances like trimmers, like this. Nickel metal hydride is the same. Then there is sodium sulfur battery. This is actually a trending battery, sodium sulfur, which is not fully developed, but this is also in the market and people are working on it. Then there is redox flow battery, sodium ion battery, and then at last I will go through lithium ion battery, which is a next generation battery. So the before going through these battery technologies, I want to give you the some industrial uses of these battery types that you can see here. This mostly the industry is using lithium ion battery because we have laptops, we have phones that is using lithium ion battery for sure. That's why it has the highest market share in the industry. Lead acid batteries also have 28% because all of the automotive, vehicle, that is a combustion engine vehicle, but still it is using lead acid battery as a starter. It has electronics inside this engine, inside this vehicle. So lead acid battery is actually covering that. And you can see the other batteries are very small in portion. That means 0.14, 0.3%. Actually, because they are now trending, they are now growing. That's why it is not that much high in the percentage in the market, but they will also, they can also prevail in the future. So we will now go through the battery types that is already existing in the market. First of all is nickel cadmium battery. Nickel cadmium battery, as you can see from the name, nickel and cadmium. So there will be nickel metal and cadmium metal in anode and cathode. When you see a positive sign, you should understand that this is actually cathode. When you see negative sign, you should understand that this is actually anode. So I said that when you are discharging, that means this place discharging, the electron should go from anode to cathode, and the electricity should go to the opposite direction. That you can see here. This is anode, and the electron is going through this side. So if you can see this reaction that is written here, there is nickel oxide hydroxide, which is in the cathode. And then when it is actually charging, this is the charge process. It actually gives the hydroxide ion, which is going through the electrolyte, which is potassium hydroxide, and it is traveling through this, and it is going to the cathode, and it is giving you the energy of as an electron. So this is the charging process, and during charging, the hydroxide ion is actually traveling from anode to cathode. But you can see in the previous state, we saw that the thing is a little bit opposite, because in lithium ion battery, when it is charging, lithium actually, which is positive ion, which is travels from the anode to cathode. But you can see here, this is negative ion, hydroxide ion. That's why you can see it in opposite direction. That's why you can see that negative ion is going through this electrolyte during this charge process from anode to cathode. And when it is going there, it is alloying with nickel hydroxide, and then it is storing there, and it is actually staying there. And then when you are taking charge from it, which is discharging process, you can see this same hydroxide ion is traveling through this, and which was actually alloyed here, and now it is actually de-alloying from this cathode and going through this section, and then the electricity is passing on the outer circuit, and you can see the overall reaction here. So this means actually the equilibrium reaction. Then there is nickel metal hydride, which is also actually I told you the working mechanism is more or less very similar. So nickel metal hydride is also working in the similar way. Just this time you will have nickel and metal hydride as an anode, nickel composite as a cathode. So there are materials which is there is material which is nickel based, and it is cathode, and this is anode. But the mechanism is more or less same. When the ions are passing, the electricity is passing over the circuit, and you can get it as an stored energy. Then there is sodium sulfur battery. As you can see, the name is sodium sulfur. So you can understand actually what is happening here. Actually, sodium is traveling through the electrolyte now. But the thing is, this electrolyte is not the normal electrolyte that you are thinking. This is actually a high temperature electrolyte. That means it is melting electrolyte. That's why this type of battery is normally used in a high temperature application like missiles, where you need where you need to produce high temperatures. So sodium sulfur battery, it is also a safe type of battery, but the thing is you need a high temperature to operate it. So the thing is, again, when it is charging, sodium is actually going from the positive section, that means which is actually containing sodium, and then it is going through the electrolyte, and then when it is going to the anode side, this is actually making a alloy which is sodium sulfur. So when it is discharging, then it is going through the opposite direction, and then it is actually exerting the sodium, and it is going to the metal side again, because now this is discharging. So the thing is, all the working mechanism is more or less very similar with the lithium ion. Just this time the sodium is traveling. So you just need to understand, when you see the name lithium ion battery, that means lithium ion is traveling from cathode to anode. When you are saying sodium sulfur battery, that means sodium is actually what is traveling through the electrolyte. That's why it's called sodium sulfur. And why sulfur? Because sodium is now intercalating or making an alloy with the sulfur. That's why it's sodium sulfur battery. So as you are not from the chemistry background or not deeply understanding the whole mechanism, just when you see the name sodium sulfur, that means you should understand that this system is actually based on sodium, and sodium ion is actually passing through the electrolyte. If you understand this is at the beginning, it would be good to go forward. And there is also a redox flow battery. Actually, at this stage, the redox flow battery is mainly used in big sized application like grid connected battery storage system, which is called spinning reserve. Because sometimes when the voltage goes down, the voltage can minimized, and the voltage sag happens. At that time, you need a backup system to do the to maintain the voltage at a certain level. And this redox flow battery actually do these things. That's why we are calling it grid connected battery system. So the thing is, at this place, the electrolyte is not exactly staying between the anode and cathode and separator. Actually, the anode and cathode is now separated, which with a membrane that you can see here is called membrane, but there is no electrolyte here. When we are taking a charge, or when we are charging it, then we are pumping the anolyte, and then we are discharging it, we are pumping the catholyte, so that when we are discharging, there is ion in the cathode that we need. So we are pumping the catholyte and then taking the energy, and when we need the when we are pumping the anolyte, then we are actually charging the battery. So just by by controlling the flow of the anolyte, which is called anode based electrolyte, and catholyte is actually cathode electrolyte. So when we need to do that, we can just make the flow of this battery, and then you can get the charge from the outer circuit, and then you can use it as a grid connection system to make it to minimize the voltage sag from the system. So the thing is, the lithium ion battery, this is redox flow battery, and then the last one is lithium ion battery, which is actually our next generation battery. Why we are calling it next generation battery? Because the lithium ion battery has the highest capacity, and the thing is, it can be used in lithium in electric vehicle systems. The other battery that we saw, sodium ion battery, do not have the enough charge or energy density that can run an electric vehicle. But this lithium ion battery can do that. That's why we are telling it a next generation battery. So the thing is that I already mentioned, because I gave the explanation with the lithium ion battery. But you can see here that when we are going to cathode, actually the electron is exerting from the cathode, and in anode, lithium is actually making an alloy with the carbon. That's why C is here and making a lithium carbon. So during this and charging and discharging process, lithium ion is going through the electrolyte, and we have this lithium ion battery system. And then there is another next generation battery, which is actually trending now, sodium ion battery. If you think why sodium ion battery is emerging when the lithium ion battery is already in the market, and it is actually a good energy density battery with lithium battery. Actually, sodium ion battery is way safer than lithium ion battery, because the sodium ion battery can use aqueous electrolyte. When I say aqueous electrolyte, what is it means? Actually, sodium ion battery electrolyte is not flammable. When we are saying that lithium ion battery is flammable, it is the electrolyte. You should understand that electrolyte which is actually flaming the battery. And the making process of lithium ion battery is a little bit complicated, because when we want to inject the electrolyte inside the battery system, the environment should be free of moisture. But for sodium ion battery, we do not need this type of requirement. You can just make an electrolyte which is water based electrolyte, and then you can put it in the middle of the anode and cathode, and then you can use it as a sodium ion battery electrolyte. So the thing is here, which you can see here. So sodium metal is actually used as anode, and sodium based composite is used as cathode. So a porous separator is actually inside that is allowing the sodium through when charging and discharging. But the thing is, sodium ion is a little bit higher in size than lithium ion battery, right? Because we can see that lithium is above sodium, and after lithium is come sodium. Sodium has atomic number is 11. So this time the separator needs to be more porous, and the pore size should be higher than the lithium ion battery, because now the traveling ion is sodium ion battery, and it has higher in size than lithium ion battery. So the thing is, when we are charging the battery, then the sodium ion from this cathode is actually traveling through this porous separator and going to this sodium actually it's a carbon anode, and then it has a sodium cobalt oxide cathode. And then when sodium is actually intercalating this time with carbon, and it is the similar process. But the thing is, now we need to get a higher distance between these graphite plates. Previously, we saw that lithium is actually very small, that can fit inside this hexagonal structure. But now this sodium needs to be inside the plate, because graphite has moving plates, and this moving plates distance is higher than the distance place inside this hexagonal structure. So sodium is now actually being inserted inside this structure, which is graphite moving structure, and the number of sodium that can be stored is less. And why less? Because sodium has higher in size, it needs more size than lithium, so it can store less energy. That's why the highest energy that we can get from sodium is 4 times less than the lithium ion battery. From lithium ion battery, the highest energy that we can get is 4200 milliamp hour per gram. That means 1 gram of lithium can give you 4.2 ampere. But sodium, when you see sodium ion battery, which is safe than lithium ion battery for sure, but it has low energy density, which is around 1200 milliamp hour per gram. That means 1 gram of sodium can give you 1200 milliamp current. So the thing is, when you see the battery, you always see the rating as ampere hour, right? It's written, for example, 10 ampere hour or 2000 milliamp hour battery. Actually, what it means, you need to understand it first, then you can understand it very clearly. When you are saying that 2000 milliamp hour battery, that means if you use this battery, and if you extract the current from there, which is 200 milliamp current. And if you get this 200 milliamp of current for 1 hour, your battery will be fully discharged. That's why it's called 200 milliamp hour. That means in 1 hour, if you take continuously 200 milliampere current from this battery, it will last 1 hour. But if you take 100 milliamp from this battery, then it will last 2 hours, because now you are taking the 50% of it current, so it will last longer. So the thing is, when we are saying that sodium ion battery is storing more energy, less energy than lithium, that means it has, if you have the if you want to have the same amount of energy, sodium needs to be 4 times higher in size. For example, if you have a battery which is 1 kilogram in weight, and you have 1 ampere hour ampere current from that, if you want to make this lithium system with the sodium system, you need to make the battery 4 kg, so that you can get the same amount of energy, but from sodium system. Previously it was from lithium system and battery system, but it is now from sodium ion battery system. So the thing is pretty much similar, just now we are using sodium, and for sodium we need more place to store, and it will take more space, and it will store less energy. And this the next battery which we will talk about today, it is lithium air battery. And when we are talking lithium air battery and lithium ion battery, this is very different, because previously we were calling it lithium ion battery. So you can understand that actually lithium ion is playing the key role here, and you need anode material and cathode material which is solid or powder in form. But this time you can get an cathode which is not actually fully solid. If you have a hole in the battery system, then oxygen can pass through it, right? So if you have anode in the lithium and you are passing it to the cathode during discharging, and when it is going to the cathode, there is oxygen there. That's why this oxygen is actually now intercalating. Oxygen is now alloying with lithium and making lithium oxide, which is Li2O2, which is lithium superoxide. There are 3 types of oxide: lithium peroxide, lithium oxide, and lithium superoxide. This Li2O2 is lithium superoxide because lithium is very highly reacting in the air, and when this lithium during discharging going to the cathode, it is actually making a lithium oxide composite. And during charging process, when you are forcing it, this lithium is actually going back to the lithium anode, because this is the lithium anode, which is lithium metal. And if you see, if you can remember the figure where we showed that a lithium metal battery is actually a little bit unsafe. As you can see, there was lithium metals using, but here this lithium anode is not that unsafe like lithium ion battery, because there is no chance of dendrite formation, because actually there is no composite material on the cathode side. There is just air bubble, which is actually making it lithium oxide during discharging, and when we are charging it, it is actually going back as a lithium. So lithium air battery is a little bit safer, but there are some problem with this lithium ion battery, because it discharges very fast. You can charge it very fast, but it is discharging very fast, and you can just cycle it for 50 to 100 times, which is not a good commercial type of battery. But researcher is still working on this lithium air battery, and also the voltage is a little bit higher for lithium air battery, but still there are some work going on which needs to commercialize it fully. So now we will talk about fully lithium ion battery, because our next generation battery is lithium ion battery. And then again, why we are calling it next generation battery, you can see it here. if you see the lead acid system, and if you have just 350 kilogram of battery, and if you put it in a electric vehicle, you can just go 50 miles. Then if you get nickel system with 350 kg, you can go 100. But if you have lithium ion system, you can go more than 200, almost 300 kilometer of driving range you can get it. But it's still, the combustion engine is way higher than this lithium ion battery. It is more than 700 kilometer if you think 50-liter tank. So why we are telling it next generation battery? Because lithium ion battery is the highest energy density than all other existing battery system. And yes, it is less than combustion engine system, but still, as we are thinking about the environment, as we are thinking that we can go fully electric system, and we want to save our environment and exert less carbon dioxide in the system, because combustion engine or the vehicles are mostly very much responsible for this type of environment hazards that we are we're facing now. The whole world is facing it. That's why this lithium ion battery is also being used as next generation battery. Actually, it has also very longer cycle life, as I said earlier, and this has no memory effect, and energy demand is also growing. So lithium ion battery is the right choice as a next generation battery. So for next generation battery, there should be something which is trending, and that's why people are still working on it. So the next generation battery, actually, as I said, lithium ion battery is actually work on anode and cathode. There is a lithium containing cathode, and there is carbon or silicon based anode. So if you think about next generation cathode, so there are you will hear it, NMC. NMC is lithium nickel manganese cobalt oxide. So NMC is very much available in the market. You can get it from the market as especially for the electric vehicles. These are very much common. And there is another one, which is lithium iron phosphate. This is actually an interesting type of battery because if you think that lead acid battery is way safer, why don't we use lead acid battery? Actually, this lithium iron phosphate battery is as safe as lead acid battery. And now this lithium iron phosphate battery is actually replacing the lead acid battery in solar energy system, in home energy storage system. They are using this lithium iron phosphate battery. And if you see here, if you see lithium iron phosphate, and if you see the other material, you will see that in other cathodes, there is some element which is toxic or radioactive, like this cobalt. This cobalt has the highest energy density in this NMC, and this is radioactive. Nickel and manganese a little bit hazardous for the environment, and it also create problem in the environment because it's toxic. But this LFP is actually lithium iron phosphate. Iron is not a toxic metal. It is all around us, and this is not a problematic for the environment. But when you see the other cathode system is actually have some either cobalt or manganese. So the only thing is lithium titanate oxide, which is here. You can see is LTO. This is also a very trendy next generation lithium ion battery. But the thing is, the LTO is not fully developed or not fully commercialized, and the cycle life of the LTO is a little bit less. I mean, way less than the FP or other lithium systems. Actually, when we say lithium battery, NMC battery, actually lithium ion battery is named after the cathode. You will see, you will hear that NMC, NMC battery, LFP battery, but nobody will say silicon or anode or graphite battery. Why? Because lithium battery is named after the cathode, because cathode is the most important element that is holding lithium. And this lithium is passing through the electrolyte to the anode, and anode is actually holding it. Anode is giving its space to be stored. So the thing is, the main chemistry is governed by this cathode. That's why the lithium-ion battery is named after the cathode. If you see in the market, if you see in the EV industry or any commercial advertisement, you will see that people are telling it NMC battery, LFP battery, LCO battery. Tesla is now working on NMC battery as cylindrical cells. There are LFP batteries as well. So the thing is, people are naming it with the cathode. So you should understand that when people are saying NMC battery, they are actually mentioning the cathode. But there is also anode, which can also be making it next generation, because as I told you earlier, the mostly used anode is carbon or graphite. But silicon based anodes are also a little bit trending right now, and I am personally working on silicon anode as my PhD thesis, and we are doing silicon synthesis through electrochemical deposition, and then we are using it as anode. So the thing is, this time we do not need to use any binder, or we do not need to do any type of toxic material to mix it. So silicon is also a very trending next generation anode that can be replacing the uh, uh, carbon or graphite cathode. But the thing is, it goes through very high expansion. As I said, and as I showed you, that when lithium insert or go inside this hexagonal structure, it actually takes an space. So when you put something inside the space, it expands, right? But graphite already have been moving apart, which is already a little bit, far away from each other in nanometer scale. But this silicon is not like that graphite, or this has no this silicon has no moving part inside. So the thing is, when we are inserting silicon inside lithium inside this silicon, it is actually expanding. And how much it is expanding, can you imagine? This can expand 4 times. That means 400% expansion happens for this silicon based anode. So the thing is, when you are repeatedly inserting and de-inserting lithium inside the system, this silicon degrade faster and delaminate faster, and that's why this separates from each other. That means the whole structure or whole continuity of the silicon breaks, and then the silicon battery degrades faster. So the thing is, people are working now. I am actually working on it as well. If we coat carbon on silicon, this cracking do not happens, or it is minimized to a level that we can use it or cycle it for 1,000 times. Because nowadays, if we use the silicon, high silicon amount in anode, next generation anode, it is actually can cycle 100 to 200 times, not more than this. So this is a very good and very trending next generation anode, which is silicon based anode, and silicon carbon as well, composite. And there is niobium oxide. Niobium oxide is a very good candidate and of next generation, because niobium oxide can charge. If we use niobium oxide anode, you can charge it faster. Maybe you are hearing it right now, that fast charging battery. In 5 minutes, your battery can charge up to 80%. After just giving 5-minute charge, you can go 800 or sorry 200 kilometer more. So what's this things actually happening? Actually, you are inserting faster lithium inside this anode. And if your anode can capable of doing this high insertion, you are actually making it a high, or you are actually making it a fast charging battery. So this niobium oxide is very good candidate for this type of battery, fast charging battery, because niobium oxide can charge the battery 5 times in higher speed than carbon anode. So if you use it niobium oxide, then your battery will be much more fast charging than the traditional graphite anode. So when you hear, if you hear next time that fast charging battery, then you should be sure that this anode of this lithium ion battery is not carbon or not 100% graphite. This has some portion of silicon or niobium oxide. You should be sure about it, because if you want to fast charge, for example, if you have a fast charging system and you want to say, okay, I have a battery in my cell phone, why can't we charge it faster? Because you don't know what type of anode it has been used. If it is using an graphite anode, and if you are fast charging it, because you have a fast charging system, you have high voltage charging system, and you put it in the fast charging, it will plate lithium on the surface of this graphite. So that will make your battery vulnerable to catching fire, because the lithium is now dendrite formation is happening, and then anode and cathode can be short circuited. And that's why if you just have a traditional battery, lithium ion battery, you cannot just fast charge it because you have fast charger, because the fast charging battery should be compatible with the anode, which should be fast charging as well. That will make your battery fast charging. So the thing is, you should also understand that this is the anode, next generation anode, that is making the lithium battery charging faster, allowing the fast charging. Then there is tin based anode as well. I also worked on tin based anode, expansion and the expansion between charging and discharging, and it is delamination. And the thing is, the energy density is lower than silicon. So tin is actually, people are working on it, but it's not that much popular in the market. So the thing is, porous anode current collector is also people are also looking for, and I am also working on it. For example, if you have more space, if you have more surface area, that means you can accommodate more space for the lithium. So people are working on it to make the current collector porous, so that you can have more surface area. And when you have more surface area, that means you have more space of putting your lithium inside. So at last, there is one thing that is I want to mention, that about the advantage of lithium and battery. That means if you see here, this is not an single lithium and battery. There is hundreds, thousands of cells. So this is a very good advantage of lithium and battery, because you can see Tesla is just producing this NMC 3250 battery, which is just as small as a dry cell. But you can tell, okay, how a dry cell or this small cell pencil battery, which is called double A size battery, can run an electric vehicle. This is actually answered here. You can see there are thousands of cells in series and parallel, which is connected here to give your car enough power and enough energy that you need, enough voltage. So the thing is, you need to understand here, when you need more current, you need to put your cells in parallel. If you have if you have for example 2 ampere, you can get 4 ampere hour battery, 4 ampere hour from this 2 parallel battery system. So the thing is done here. If you want to make the battery, for example, 500 ampere hour, then you need to put 500 battery in parallel. And if we have one each is capable of supplying just 1 ampere, then your 500 will give you 500 battery in parallel. If you need higher voltage, if you have higher voltage motor system, electric motor system, which is 100 volt, and if you just have 33 lithium ion cells putting in series, you can get 100 volt from this voltage system. So that's how this parallel and series combination can give you a full battery pack, which is possible in the lithium ion battery, because it has enough space for energy, and it is very high in energy density. So higher, there are some challenges as well for the lithium ion battery, which is also you need to consider. The cost is also high right now, but researcher and companies are trying to make it less costly. And now you can get per kilowatt hour battery of lithium ion battery in as low as $100. I mean, if you have for example, actually the most expensive element of an electric vehicle is the battery. So if we want to make the electric vehicle more available to people, more accessible to the people, we need to minimize the cost of the battery, at least the lithium ion battery, because it is a costly battery, as you can see, because a pencil battery or double a size dry cell is just maybe a couple of cents, but a lithium ion battery is maybe a couple of dollars. So the thing is, when you are using thousands of them, so you need to put thousands of dollars for the battery only. So the thing is, these things is also needs to be done, and there are some environmental hazard as well. As I told you, lithium battery is using cobalt, manganese, nickel. They are also a little bit hazardous, but LFP battery can also replace this, and lead acid battery as well, and this is not toxic for the environment. So at last, there will be an overview of the global market trend of the lithium ion battery market. If you see here, the automotive industry or EV industry is currently using just 35% of lithium ion battery, which is available in the whole market. That means 35% of the lithium ion battery is using in automotive industry. Still, the consumer electronics is leading. It has 41% of use, because we have laptops, we have mobile phones, we have other electronics equipments that is using lithium ion battery as well. So there are some other grid connected energy storage system, as I told earlier, that people are using it as well. So lithium ion battery is actually a trending battery, and it is actually taking over the whole battery market. And in next 10 years, it will be the mostly used battery. Right now, the job market is also very trending and very high in demand. As I am also a lithium and battery expert, or lithium and battery professional, I can tell you, people are offering me every week. They're offering me good positions in a lithium and battery in industry, or lithium and battery engineering positions. So the thing is, lithium and battery is growing. It will be growing in the future. And the thing is, if anyone wants to know about the lithium and battery, and if he's expert of that, the future is very bright, I can tell, because as the students are also wants to study the subject that is very much trending and high in demand. So if anybody is thinking about his career, he can definitely think about lithium and taking in consideration for his future career prospect. So that's all from me, and thanks for listening. And I would be happy to clarify the questions if you have any.
Thank you very much.
And thanks for listening. That's all from me.
Thank you very much for your very scientific, data-intensive presentation. One of the most awesome that we have had at Atlantic International University. I thought that I knew about batteries, not the actual mechanism, not actually the elements of battery science, but I thought, since I'm using different types of devices that use batteries, I thought I knew or I understood which battery to go for, and so forth and so on. Your class has changed that completely. As someone, I am very, very thankful, very grateful to you. And I have no doubt our participants are of the same point of view. So let's now, like you allowed us, let's turn the floor to them. You may close your presentation, if you don't mind, so that we can see all the participants, and if anybody raises hands, we can quickly detect that hand and allow the attendee to ask questions. Ladies and gentlemen, we just had Professor Ikramul Hasan Sohel from the Istanbul Technic University. As you all would agree, he is a true expert in that field, and what we got from him was really a top-notch, world-class presentation. Thank you very much, Sohel. And now, ladies and gentlemen, the floor is on your end, on your side. Go ahead, please make your questions. If there are elements of the process of charging, discharging, why is it that Lithium batteries are the trending type, like Sohel indicated? Any type of question. You know, we ask questions because there are things that we don't understand quite well. And Professor Sohel is here with us and waiting for you. I am moving my eyes all over the screen to see if anyone would ask a question, make a comment, and so forth and so on. Now, as we are waiting for questions from the students, let me try to bring up something and answer a question myself. Like I said, Hassan, like any other human being nowadays around the world, I use batteries constantly, but very often, I don't know if, you know, it would be better for me to have a rail vac type or a dual cell energizer and so forth and so on. Some of the trending manufacturers around. Tell me briefly if there is a type of battery, a brand of battery that is better than some others, and which type of batteries would you recommend that we, the consumers, purchase?
Okay, so if you want to understand what would be the right battery for you, you need to understand the application. And when I'm telling the application, the thing is how much heat it can generate in that application. For example, if you are using in a mobile phone, your mobile phone is not gonna be heated that much because you are just using it in hand and it has not that heated environment. But if you are using it in a car, and that is already moving part, and that is already, there are a lot of heating elements inside it. It is working outdoor. It has rain that's falling on that. So the thing is, when you are trying to choose a type of battery, you need to first think what temperature and what environment it is actually going through. So when it is going through a normal environment, you can just think about the battery capacity, how much capacity it can give you, how much energy density it has, not much thinking about the safety, because safety is not a very crucial here, because your application is very, not that much in hazardous environment, or not that much, dangerous environment. So the thing is, for example, if you are thinking that your place is limited and you want to store energy in this limited space, you should also think about lithium-ion battery. As I told you, lithium-ion has the highest energy density. So if you have a constraints in the space, then this is also a constraint. That means you need to think about that what space I have and how much energy I want in that space. So the thing is, regarding your use and the application, you should select the battery accordingly. And if you have more energy density requirement, go for the lithium ion battery, NMC or LMO, LNMO. But if you have less energy but higher in safety issue, then you should go for LFP. For if I think about only lithium battery, But if you think, okay, I can also go for sodium battery, lithium battery, lead acid battery, and I can choose between these technologies, then I will tell that if you have sodium ion battery available to you, and if you need very high safety and you are very much concerned about the heat or about the fire, go for the sodium ion battery. So that's how you should think about.
Okay, thank you very, very much for your candid response. Let me quickly read for you a question that popped up on the chat line. The student has not raised a hand around from the, we're gonna go to Bismarck in a second, but since I announced that question from July, Hamu Tuto, and this is what that participant asked: what makes the Leon battery so expensive compared to sodium sulfur types of batteries? Ladies and gentlemen, we seem to have a little issue at this time. I just read the question from July Hamututo, but I'm looking around. Oh, okay. Ikramul had disappeared, but he is back. Thank you very much, Ikramul.
I hear your question. I mean, what makes the lithium ion battery most expensive, right?
Correct.
The question is that. Okay. Actually, as I told you, the material, the lithium itself, is not that abundant in the environment are actually producing lithium, and one of them is Argentina and Australia. They have the most lithium reserve of the world, Argentina and Australia. So because of lithium ion battery is mostly use the rare earth material, which is not exactly very much common in the market, and you can just go and buy. That's what makes it expensive. And also there are some system that I told you, the electrolyte needs to be very well intact. There should be no moisture. So the making process of lithium ion battery is also expensive, because I worked in a lithium ion production facility in Europe, and the whole the most of the expense was going through the dry room to make the environment of the production facility dry. This was the most expensive portion of the if you take section by section, it's called dry lab, and I was also working in that dry lab. So that's the thing that is make it expensive. The material itself is expensive, not so much available, it's rare material, and the making process of lithium ion battery is also making it way more expensive than we can think at the beginning. But it worth this expense because it has very good energy.
Okay, that was a response from somebody who is truly knowledgeable about the topic of battery science. What about you? What is your question? What is your comment? Bismarck, Yamira? Go ahead, we are listening to you. Bismarck. Are we losing Bismarck, who has raised hand? If Bismarck is gone, okay, go ahead, Bismarck.
Yeah, good afternoon, sir.
Good afternoon.
Good afternoon.
Yeah, please, I want to know the difference between the solar energy batteries and the car battery, and what keep them longer, because the solar batteries get its energy from these solar panels. So I want to know the difference between those two types of batteries.
Thank you.
Okay, sure. Thank you. Thank you for your question. Actually, as I already mentioned that lithium ion battery can also be used as a solar system battery, but one special type of battery, which is LFP, lithium iron phosphate. This has this is very safe than other battery, and this is non-toxic. This LFP battery is being used in solar system. But in car system, if you think that in the energy density of LFP is not that high like NMC. So as I said, if you have less energy, your size of the battery is growing, is very big. So if your car battery is taking 1 ton, 1000 kg, so how much it can carry? So it will be very heavy and it will be very expensive to run the motor, and it will take a lot of current, lot of energy.
Okay, I'm really impressed. Let's maybe take the last question from Orwin Bassam. I spoke with the presenter, Ikramul Hasan Sohel, right before the session started, and he was telling us about a weather condition in his area, which probably is causing those down times within his system. So let's take the last question. Hopefully, Ikramul will be able to answer. Oh, well, Bassam, we are on your end at this moment. Orwin Bassam.
Can you hear me now?
Yes, go ahead, sir.
Right. Thank you very much for that insightful presentation. I want to know, why is it challenging when it comes to importation of lithium batteries? The transporters, they are usually very weary, especially when you are importing large size for projects.
Okay.
So, about maybe 600 megawatt hour battery. They are weary about importation, shipping. Why is that?
Okay, so battery shipping concern. Yeah, actually, the thing is, when you are shipping the lithium ion battery, you cannot ship it fully discharged. You should charge a battery to a certain level, for example, 60% or 40%, depending on the battery technology. Okay. So when you are actually charging a battery, it's always have some discharging of self-discharging. When you are putting a battery in the shelf and you are not using it, it is normally self-discharging because it has internal resistance, which is actually causing this self-discharging. So the thing is, when you are shipping this battery to a long distance, for example, 1 month or 2 months, then this concern become much more crucial, because
once again, ladies and gentlemen, I want to apologize for these moments.
Yes,
anyway,
sorry.
I'm sorry. Go ahead, Ikramul.
Yeah, sorry for that, because we are having the storm here. That's why it's still dark outside.
Yeah, we are about
That's
to
why this thing is
conclude.
happening. Sorry for that.
That's
so
okay.
I thought that if I stop the video, it will be good. But when I stopping it, it's stopping the Zoom.
Yeah.
Okay. So the thing is, when you are charging it and when you are putting it, sending it to the in a longer distance, it is getting more chance to be discharged, self-discharged. And as they said that the environment should be very dry. If you are transporting it through the sea, then there will be a lot of moistures and there is water. So when it comes close to the contact of the water, it can catch fire, because lithium ion battery electrolyte is very flammable, as I told earlier. So that's why people are very concerned about this some transportation. But researchers have found that if we have found a minimum amount of charging level that is enough for lasting for 1 month, so that it goes through less self-discharging. do not need to be charged 60% or 80%, maybe 20 to 25% charge would be enough. So they are also working on it to optimize the system. Thank you.
Once again, we highly appreciate your effort to do this presentation for Atlantic International University, Professor Sohel. We do understand, like you indicated, Sohel. I'm sorry, Ikramul Hasan Sohel. We understand that you are going through a storm at your location, and you've anyway made the superhuman effort to be with us for this presentation. All our participants are also grateful to you, and we are putting an end to this class session, ladies and gentlemen, reminding you that that information, of course, was highly data intensive, so to speak. And to understand it fully well, you would have to go through the presentation or to get acquainted with all the details presented by Professor Sohel. And I'm asking you to simply be patient. If you don't get the link, let's say between today and tomorrow, be patient. You will receive it by within an acceptable amount of time or timeline. It's going to be with a link to your email or on your student portal at the platform of Atlantic International University. We appreciate also your cooperation, and we thank you as well, ladies and gentlemen, for having taken the time to join us for this live class presentation by Ikramul Hasan Sohel on the topic of battery science. Thank you very much, everybody. If you want to
thank you
to knowledge the presenter, I am turning all your microphones on at this time, so we can say thank you, Professor. Your presentation's been outstanding. Thank you very much. Be blessed.
Thank you. Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you. Thank you. Thank you very much. We really appreciate it.
Thank you.
Be blessed.